Hi everyone! Our lesson for today is going to be starting quadratic word problems. So this is going to be where we start to look at some real-life applications of quadratic functions. And so for today we're going to actually talk about, to start, 3 different situations, talking about a football player, a baseball player, and a tennis player. So it says to graph the following functions on your graphing calculator and adjust the window so you can clearly see all 3 graphs. If you don't have your graphing calculator at home, you can try and log on to Desmos. I'm going to write it up here. I mentioned this in class before. This is an online graphing calculator, and I don't think it has all of the capabilities of our Inspires that we use in class, but for now, you should be able to do graphs, and so I would check that out if you don't have your own graphing calculator. So if you have a second and you want to pause the video and you want to play around with getting your 3 graphs onto a calculator and adjusting the window so that it looks just like the picture here, you're absolutely welcome to do that. Okay, so whether or not you've tried that, let's start talking about what these graphs are. So there's 3 different parabolas here, 3 different equations, and it says these 3 graphs depict projectile motion created by a football player, a Little League baseball player, and a tennis pro. The units being used are feet and seconds. Based upon the descriptions below and your observation of the graphs, match each graph with the athlete that created it. So we're going to go through and we're going to try and match the player with the correct equation. So first things first, if you can tell, all of our equations have a leading coefficient or an A term that's negative. And that's what makes our parabolas all open downward. So that's why for all 3 quadratic functions that you see graphed there, they're all opening downward because the A term is negative 16 for all of them. The other thing I want to point out about these equations is that only one of them has a y-intercept that is not 0, and it's that last one. If you see that plus 75 on the end, that right there is showing you that that parabola crosses the y-axis at 75. The other 2 cross the y-axis at 0, which means in the picture, if you look above, they're starting at 0. Okay, the middle term is something that we haven't talked about before. This is new to us. So when I say middle term, I mean the B term, the one that's the coefficient of x, or in this case, t. So the 112 and the 64. Those numbers represent velocity, or initial velocity. Remember, velocity is almost like a speed, or rate of change in whatever units we're talking about per whatever time we're talking about. And so let me go back. Does it say? It says the units being used are feet and seconds. So in the first equation, we'd be saying that the velocity of whatever ball we're talking about is 112 feet per second. So that's what that middle term represents. Okay, so looking at our different situations here, let's try and figure out which equation matches for a Little League baseball player throwing a baseball straight upward. Okay, so I would look at, first of all, the fact that there is a y-intercept of 0 and its velocity is less than, let me just look, would be less than a tennis pro firing a shot straight upward. Okay, that velocity is going to be a lot greater because if you think about hitting a tennis ball versus throwing a baseball, that ball is going to travel a lot faster. So I would say, why don't we go ahead and assume that that first equation actually goes with the tennis pro, because that has the biggest velocity out of both equations, and that is going to be the easiest way to do this, I think. So now what we're doing is we're comparing the Little League baseball player versus the football player. So it says the football player is standing atop a school building and throws the football straight upward. So if you look at your equations, basically they're exactly the same, Besides that, the last one has a y-intercept of 75. So if you think about the fact that that football player is standing on top of the school, which doesn't seem too safe, it makes sense that that equation would go with the football player. And so this middle one must be our baseball player. Okay, it's a little process of elimination there. So question one says, on each graph, what does the x-axis represent? So in this case, we're talking about time versus distance. And so the distance depends on the time. So time is our independent variable, which means that's our x, seconds. What does the y-axis represent? That is going to be our feet. What did I write here? Time versus vertical distance. Okay, so go ahead and turn the page. And we are going to be looking at the Little League baseball player graph to start. So remember that equation, let me write it up here for us. The Little League baseball player's equation was negative 16t squared plus 64t. So it says, what was the initial velocity with which he threw the baseball? So remember I said initial velocity is your b term, which in this case is 64, and I would want to make sure I label that 64 per second. The initial height of the baseball is your c term, which in this case is 0, so I would say 0 feet. The maximum height reached by the baseball. So in this case, your maximum height is going to be whatever your y-coordinate of your vertex is. Okay, so this is where you're going to have to, on your graphing calculator, use the menu Analyze Graph and find the maximum point, and it's going to say lower bound, upper bound, and you're going to go a little to the left of that point for lower bound, a little to the right of that point for upper bound, and it should pop up the point that is considered your maximum. So if you didn't graph that equation before, now's the time to put it in your calculator and see what you come up with. So if you want to pause the video here and take a couple minutes to figure that out, and then you can start it up again. Okay, so if you've done that, you should have found that the maximum height was 64 feet. Okay, so then it says, for what length of time was the baseball in the air? So again, using your graph, we are looking for, I'm going to do a little sketch here. This was your baseball. So we want to know what this point is, because that point will tell us when that baseball basically hits the ground, and so it's not in the air anymore. So for this on your graph, you guys are going to go into Menu again, Analyze Graph, and then you're going to go to zeros. Zeros is another word for x-intercepts, roots, lots of names for it. Okay, and again, it's going to ask you lower bound, upper bound, and you are going to figure out the x-coordinate of that point. So take a second, pause the video, see what you get. And you should be seeing that that point is 40, which means it was in the air for 4 seconds. Okay, the last part here. After 3 seconds, what was the height of the baseball? Okay, so now remember, seconds is our time, which in this case is our x value or our t value. So one way that we could figure this out by hand is by putting 3 in anywhere we see a t in our equation. But since we're using our calculator for these, let's continue to do so. So if you can pull up the table, Control T, you want to look on the table where x is 3, because that will tell us what the height of the baseball is after 3 seconds. So on your table you should see when x is 3, y is 48, which means the height of the ball is 48 feet after 3 seconds. Okay, so now we're going to talk about the football player. So I'm going to go back really quick and write down the formula for you again, or the equation. This one was negative 16t squared plus 64t plus 75. Okay, so how tall was the school building upon which the football player was standing? Well, because our y-intercept isn't 0, we're going to say 75 feet for this one. What was the initial velocity of the football? Again, that's our b term. So in this case, 64 feet per second. What was the initial height of the football? So that's basically saying the same thing that part A was asking. It was 75 feet because that's how tall the building was. What was the maximum height reached by the football? Okay, so we're back to our calculator. If you haven't already, make sure you get that graph. Find a good window. If you're struggling to find the window, by the way, sometimes you can do a zoom out and then adjust it from there. Otherwise, you can make some educated guesses about how high your graph should go, how low it should go. So it might take a few minutes. That's normal to try and get a good window. So if you need to pause the video, you can do that. Okay, so part D, what was the maximum height reached by the football? So just like we did in the last one, we're going to go into Menu, Analyze Graph, find maximum, do a lower bound, upper bound, and we are looking for the y coordinate of that point because the x coordinate tells us at what time the ball reached the maximum height, but I'm asked what the maximum height is, so that's the y coordinate. Okay, so if you did it correctly, you should be getting 139 feet. Now part E says, after how many seconds did the football reach its maximum height? So using that same point you just found, it's saying, okay, well, what time did it hit 139 feet? And so the x coordinate of that point was 2 seconds. And lastly, after how many seconds did the football hit the ground? So again, here's the point we're looking for. It's the x-intercept. That's where the ball is hitting the ground. And so, again, go into Menu, Analyze Graph, and we're looking for the 0. So 0, x-intercept, roots, those are all the same. The calculator calls them zeros. Do a lower bound, upper bound. And because it's saying how many seconds, we're looking for the x-coordinate. And you should be seeing, got it correct, that it was 5 seconds. Okay, one more, back to the tennis pro. So this is the one with the big initial velocity. Negative 16t squared plus 112t. So initial velocity from which he fired the tennis ball, that's our b term, 112 feet per second. Initial height of the tennis ball, that is our c term, which is 0. The maximum height reached by the tennis ball, so here we go with our calculator. Okay, get a good window. Pause the video, find the maximum height. Okay, if you did it correctly, you should have gotten that the y-coordinate of the maximum is 196, which is exactly what we wanted. And part D says, after how many seconds did the tennis ball reach its maximum height? So same point we're talking about, but now I'm looking for the x-coordinate of that point. So if you still have that pulled up, you should have seen that it was 3.5 seconds. So after 3.5 seconds, it reaches its maximum height. And lastly, for what length of time was the tennis ball in the air? So when does it hit the ground? Because that will be the time that it was in the air for. So that's another 0. So take a second, Menu, Analyze Graph, 0, lower bound, upper bound. And remember, we're looking for the x-coordinate now because I want to know the time. The y-coordinate should be 0 because it's hitting the ground. beginning 7 seconds. Okay, that is all for this lesson.